Today we're going to be talking about angles of triangles. First off, the triangle angle sum theorem tells us that the sum of the measures of the angles of a triangle is 180 degrees. We're going to take a look at a little example to see why this is true. Here we have a picture of a triangle. It has three angles, A, B, and C, whose measurement is on the screen right now. Angle A is 30.5, B is 32.4, and C is 117.2. Now, from time to time with this geometry sketchpad program that we use for examples, we round off our answers to the nearest tenth, so it kind of is a little misleading as far as it doesn't equal 180, but let's take a look and see what this triangle does. As we move that triangle around, all of those angles continually change, but the sum is always equal to 180. So if I move point B around, you notice all the angles are all changing again, but the sum's staying 180. I can move also angle C around, and we have all kinds of angles changing measurements constantly, but the sum is always staying 180 degrees. No matter what happens with the triangle, all three interior angles will always be 180 degrees. So we have a little equation here that says if I add up angle A plus angle B plus angle C, I will always equal 180 degrees. The third angle theorem talks about the interior angles of a triangle and what must be true, and we know some information about them. We have this statement on the screen that says, if the green is true, then the red is true. The part that I'm going to give you is that between these two triangles, we have two congruent angles. The angle on the top of both of the triangles, right here, is congruent to the angle at the top of this triangle here, and the angle at the bottom corner of this triangle is congruent to the angle in the bottom corner of this triangle. What we can state is, if two angles of one triangle are congruent to two angles of a second triangle, then we can now say that the third angle from the first triangle must be congruent to the third angle of the second triangle. What we're saying is that when we know two angles in one of the triangles and two angles in another triangle and they're equal, then that third angle must obviously be the same between the two triangles. How about this picture? Now we only know two angles there. We only have them numbered 1 and 2. But if you remember from our previous lesson, this square in the corner means that we know this angle down here is 90 degrees. We have a right triangle. So what can you tell me about angles 1 and 2? Well, obviously from the looks of them, they're acute angles, but that really doesn't tell us much about their measurement. What you can actually tell me about their measurement is that if we add those two angles up, we're going to also equal 90 degrees. We now have a new statement. The acute angles of a right triangle are complementary. Complementary, as you remember, means add up to 90 degrees. A new term here is exterior angle. We've talked about exterior angles before in chapter 3 when we talked about alternate exterior angles. We have a similar concept here with this exterior angle, but it's a little easier to understand this exterior because it simply means outside of the triangle. Be careful when we talk about it though, because there are different ways that people can look at the triangle which could actually throw them off a little bit. As we look at this triangle on the top of the screen, the exterior angle would be the angle that I marked with the red arc. The green arrows are pointing to the remote interior angles. So we have remote interior angles and one exterior angle. They are all marked on that top picture. if we go to the next picture down, if I was to use the angle that is marked with the green arc or the red star, there's actually nothing that we would consider to be interior to that. That angle is not connected to the triangle. We would actually have to call that an adjacent angle. Nope, a vertical angle. Our adjacent angle is the purple one. Now we could use our exterior angles over there. It's a little different look, but the purple star does actually count as an exterior angle. Here's one more case for you, and this case is not an exterior angle. In order to be an exterior angle, it has to be on one of the sides extended. Notice how this is neither on this side extended, nor is it on this side extended. The exterior angle will always make a linear pair with the triangle. The two angles I just circled in red would be a linear pair. The one to the right side, which is outside, would be our exterior angle. Here's an example of the exterior angle theorem. What we have with the exterior angle theorem is angle 4, the exterior angle, is going to be equal to angles 1 and 2, the interior angles. Notice how angle 4 is exactly the same as the addition of angles 1 and 2. That will always be true with the exterior angle theorem. We have angles 1 and 2 are equal to angle 4. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Now we're going to try and put some of this into practice. We want to find the measurement of angles 1, 2, 3, 4, and 5. These pictures can sometimes be a little bit confusing, but try and just take small parts of them to see if that will help you to find the answer that you're looking for. What I'm going to start with would be this picture right here. Angle 1 would be my exterior, and angle 38 and 32 would be my remote interior. I now know that angle 1 equals 32 plus 38, which is 70 degrees. I now know angle 1. Now we don't always have to go back to the same theorem or same definition in order to find our answers. In this case, I'm going to use my 70 degrees to find the measurement of angle 2. Angle 2 is a linear pair with angle 1. That means they need to add up to 180 degrees. Angle 1 is 70, therefore angle 2 is 110. Now I'm going to use that 110 degrees to find angle 3. Angle 2, which measures 110 degrees, is right here. Angle 64 and angle 3 would actually be the remote interior to angle 3, which measures 110 minus 64, which would give us 46. Angle 64 degrees and the angle with the 3 in it need to add up to 110 degrees. We now know that angle 3 is 46 degrees. On to angle 4. Angle 4 is actually going to be a linear pair with the angle that I just marked with an arc. We know that angle 3 is 46 degrees. That means we have 78 degrees on the green arc side, which means angle 4 would have to be 102 degrees because it has to make a linear pair. We now know angle 4 is 102 degrees. Going back to this pair of angles right here that I'm marking with the black arc, they total 78 degrees, as we remember. That is the exterior angle, and angle 41 and angle 5 are going to be the remote interior. That means that 78 minus 41, which gives me 37, will be angle 5. We now have all of our angles. One more question here. Find the measure of each angle of this triangle. Do you know how to do it? Well, one of the first things we learned about triangle is that if we add up angle C plus angle B plus angle A, the three interior angles of a triangle must add up to 180 degrees. So we take the three angles, 3x plus 8, 4x plus 9, 8x minus 12, and add them up to get 180 degrees. Now we just have an algebra problem to solve. We get 15x plus 5 equals 180. Moving the 5 over, we get 15x equals 175. And if you reduce your fraction, you'll get 35 thirds. Plug that value back into the three equations that we had to start the problem, and we'll have the measurements of the three angles of the triangle. If you had any questions or any problems on today's lesson, make sure that you note them in your notes and bring them to class and ask me. Have a great day.